All right, mathematicians, we are moving right along. So this is lesson 1.3. This is on page 15. Okay, so page 15, go ahead and fill out your table of contents. Now, don't look at the date on my iPad because I'm filming this the day before. So this should be October 29. Okay, so our focus question here is, what is the pattern of change in a linear relationship? Okay, now we may already have an inkling as to how to answer this, but hopefully after this lesson, it'll kind of solidify what you guys are thinking. So let's go ahead and start. So again, we're talking about that walkathon. So each student from Mrs. Cruz's class found sponsors who are willing to pledge money to the following descriptions. So Leanne's sponsors will donate $10 regardless of how far she walks. Gilberto's sponsors will donate $2 per kilometer. And Alana's sponsors will make a $5 donation plus 50 cents per kilometer. So the class refers to these as pledge plans, and we're going to do some things with tables, we're going to do some things with graph, equations, and figure out, well, what indeed makes a linear relationship? What patterns do we notice? Okay, so the first thing that I need you guys to do is, I need you guys to, actually before we fill out this table here, I want to talk about what are the dependent and independent variables. Okay, so remember, independent variable is the variable that kind of stands alone. You actually have control over this variable, okay? Whereas the dependent variable it relies directly on the independent variable. So when the independent variable changes, the dependent variable kind of follows suit, okay? So I'm sure you guys have said that the independent variable would be the kilometers walked, right? Because that's what we can control. We can control how far we walked. And then what follows suit, right? What happens the farther we walk? Well, the amount of money changes. So I'll just put a dollar sign there for the amount of money. We could also think of it as distance, okay? All right, now what I want you guys to do is go ahead and fill out the pledge plans, okay? So we're going to figure out, well, how much money is Alana, Gilberto, and Leanne, how much are they going to make from 0 kilometers all the way to 6 kilometers? Okay, once you're done with your pledge plan, go ahead and try and graph, okay? Just make sure that you guys are using, so you guys are reminded. You guys remember you need to use 3 different colors. One for each student, okay? And then we have Leanne. Okay, then the second thing, I'm gonna write this in red. When you are graphing lines, you must use a ruler, okay? Like I said, if your lines are not straight, if they are not nice, crisp, and clean, you'll be getting minus points, okay? Especially on a quiz or a test, I'm letting you guys know now. It is very important that your lines are straight. Okay, go ahead, pause the video, take about probably 3 minutes. I think it should take you guys about 3 minutes. If not, we'll take about 5 minutes to answer, to fill out the table and then graph your pledge plans. Okay, so hopefully you pause the video, and we're going to talk about this really quick. So I think the easiest person's table to fill out is Leanne, because Leanne's sponsors will donate $10 regardless of how far she walks. So even if Leanne, for some reason, just I'm tired, I don't want to walk today, so she doesn't walk any distance, she walks 0 kilometers, she will still get $10. If she walks 1, she'll get 10, 2, 10, all of these she will get $10. So that's pretty nice. Gilberto's sponsors will donate $2 per kilometer. So if Gilberto doesn't walk any kilometers, he's not getting any money. And similar to his walking rate, he's getting $2 per kilometer. So there's $2, $4, $6, $8, $10, and $12. And then lastly, you have Alana. Alana's sponsors will make a $5 donation plus 50 cents per kilometer. So something to notice about Alana. When she walks 0 kilometers, right, that 50 cents, Doesn't exist. It's not there because she didn't walk any kilometers. But does the $5 exist? Yes, it does. So that $5 you guys got to think about as a flat fee here. This is a flat donation. So regardless of whether or not she walks, she's getting that $5. But then now every time that we increase by 1 kilometer, she's getting an extra 50 cents. So we're going to write this in money terms. There we go. So every kilometer she's gaining 50 cents. And I'll go ahead and add the decimals there. Excellent. Okay, so let's go ahead and graph these. So Alana starts at, actually we don't have labels here. Let's go ahead and label our axes. So I'm just going to label the x-axis by, by ones. And then how many do we have? I guess I could go by 2s possibly. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually, no, I could go by 1s as well. So 1, 2, 3, 4, 5, 6. Okay, there we go. So let's start with Alana. So at 0 kilometers, Alana already raises $5. So boom, there we go. So she starts there. And then let's see, let's find a nice easy number. So for 2 kilometers, so 2 kilometers, she raises $6. 4 kilometers, she raises $7. 6 kilometers, she raises $8. And if we were to continue this trend, you would notice that it continues in a similar fashion. So we can extend her line all the way off the graph. Just in case she decides to, go beast mode and walk all the kilometers. Okay. Now, next, let's graph Gilberto. If Gilberto walks 0 kilometers, he is making 0 money. And remember that he is increasing by $2 every kilometer that he walks. So at 3 kilometers, he is at 6. 4 kilometers, he is at 8. 5 kilometers, he is at 10, and so on and so forth. We're going to go ahead and draw his line all the way through the graph. There we go. Okay. And lastly, we have Leanne. All right, Leanne's graph is going to be a little strange. So let's start with this. So at 0 kilometers, how much does Leanne make? Well, that's going to be $10. At 1 kilometer, how much is Leanne making? $10. You'll notice that her graph continues in this fashion here. No matter how many kilometers she walks, she's just going to be at this 10 line on the y-axis. Oh, my line's kind of, don't like the line there. Let's see if this is better. There we go. That's much better. Okay. So there we have all 3 lines. Okay. So now what we're going to do is we're going to write equations for these lines. Yes, because equations are important. For each pledge plan, write an equation that represents the relationship between the distance walked and the amount of money donated. In other words, I want you guys to write an equation for I don't think they tell us variables, so I'm going to give you guys some variables here. So write an equation for A. This is the amount of money. And I want you to write it in terms of D, distance. Okay, so, what I'm asking you guys to do is to write an equation for A. So here's Alana's equation, right? I'm sticking to my color scheme here. So when the question asks you to write an equation for A, that means you're going to set A equal to something, okay? So we need to think about, well, what's happening with, in words, how can we describe how what Alana's sponsors are doing? Well, remember that they are donating $5, right? And then she's earning 50 cents per mile. So we're adding 50 cents or 0.5 per mile, per kilometer And so we get something like this. And it says, explain what information each number and variable in the equation represents. So this 5 represents, hopefully you guys said, the flat $5 donation. This is 50 cents. And this is the number, or D stands for the number of kilometers. And then we of course cannot forget A, the amount of money. And this is in dollars. Okay, so let's go ahead and go ahead and pause the video here. See if you guys can write equations for Gilberto and Leanne. All right, hopefully you pause the video. And for Gilberto, right, we are writing an equation for A in terms of D. So you will notice that his equation looks a little familiar. So remember, he earns $2 for every kilometer. We're going to go ahead and label these. Yes, we're labeling all of these because it is just a good habit to get into. It's probably a good habit to get into because, I don't know, I feel like it's better to know what you're writing and to understand what each part means, right? It kind of makes sense. So this is $2, and then the D represents, well, the number of kilometers. Okay, and then lastly, Leanne. We know Leanne earns a flat $10 no matter how far she walks. So Leanne's equation looks like this. A equals 10. And we're labeling again. A stands for amount of money. And 10 represents the flat $10 donation. Okay. So now what we're going to do is we're going to analyze some stuff. Okay, so you guys are going to have to notice some patterns. You guys are going to have to put those patterns into words. Then you're going to have to tell me, well, how do you see those patterns in the table? How do you see those patterns in the graph? How do you see those patterns in the equation? Okay, so it says, before I let you guys work, it says for each plan. So yes, you're writing one for Alana, you're writing one for Gilberto, you're writing one for Leanne. Okay, what pattern of change between the two variables do you observe in the table? So I'll help you guys out with this one, but then I think you guys can answer the rest of 1.3 by yourselves or in your groups. Yeah, okay. If you guys finish early, you guys can go ahead and move on and keep going, right? You guys can honestly work until page 20, until the end of the lesson, okay? But I'm going to chunk it down. So I'm going to give you guys for question 1.3. Sorry, I'm getting ahead of myself. Let's answer 1.3.1 together. What pattern of change between the two variables do you observe in the table? So in the table here, between the two variables, remember the two variables are the amount of money and the distance walked. Right, so for Alana, I'm just going to write A for Alana. So when the distance increases by 1, what happens? Well, the donation, hopefully you said this, the donation increases by 50 cents. Okay, Okay, so there we go. There we have a first pattern for Gilberto. I'll just write a G. When the distance increases by 1, what do you notice is happening in the table? Well, hopefully you said that the distance or the donation increases by $2. So we're going to write this down. When the distance increases by 1, by $2. And then lastly for Leanne, what happens when the donation or the distance increases by 1? Well, remember, Leanne's donation is not changing whatsoever. So we're going to write that. When the distance increases by 1, the donation remains the same. In other words, we can say it increases by 0, right? I'll put that in parentheses. It increases by 0. And I'll show you why I'm writing this in a second. Okay, now that we've answered 1.3.1, I'm going to let you guys answer 1.3.2, 3, and 4. I'm going to give you guys about 5 minutes. Work in your groups, talk to each other. Okay. All right. Hopefully you pause the video. We're going to talk about this here. So how does this pattern appear in the graph and in the equation? Well, for this one, actually, we don't need to... I don't think we need to... Really, the only one we need to write something else for is Leanne. But for Alana and Gilberto, we can kind of generalize the two. So it can save us some space here. How does this pattern appear in the graph? Well, we could say, and I'll write in red here, and this is for Alana and Gilberto, that when the x-coordinate, right, we're talking about a graph here, when the x-coordinate increases by 1, the donation increases by, I guess we could call it a donation rate, right? Because they're donating at a rate of 50 cents per kilometer or $2 per kilometer, okay? But in Leanne's case, what can we say? How does this pattern appear in the graph? Well, the graph does not increase or decrease. It stays at 10. It stays at 10 the entire time. No matter how far Leanne walks, it's always staying at 10. Okay? How does this pattern appear in the equation? Well, remember, in the equation, right, we multiply the independent variable by some sort of rate or some sort of number. Well, in this case, we're multiplying the independent variable distance times either 50 cents or we're multiplying it by $2, right, for Alana and Gilberto. So we'll say that in an equation, the independent variable, or the IV, is multiplied by the donation rate. And then let's talk about Leanne. How does this pattern of, when the distance increases by 1, the donation remains the same. How does this, how does this come up in the equation? This is our equation here. Well, you guys will just notice a constant 10, right? You guys will notice that there's just a 10 by itself. So this 10 here represents the pattern. Of the flat $10 donation. And there we go. Okay. For the length of this video's sake, I'm going to skip 1.3.3. This is actually a focus question that you guys should be able to answer, so I don't think I need to go over it. But I do expect you guys to answer this, okay? And then lastly, we're going to talk about, does this relationship represent a proportional relationship? Well, remember, we talked about that at the very beginning of lesson 1.2. So what you guys need to do is create some ratios, see if the ratios are equivalent, and then that's all you got to do. So let's test for Alana. Going back to our table all the way back here. I'm going to test some whole numbers, so I'm going to test those and those. So I already forgot my numbers, 2, 6, and 4, 7. So independent variable over dependent variable. Are these two things the same? Well, you'll notice that you can multiply 2 to get 4, but if you need to multiply the denominators by the same number, that is not what we get. So Alana is not proportional. There we go. Okay, so next let's take a look at Gilberto. Gilberto, we're gonna use the first two. So 1, 2, 2, 4. 1, 2, 2, 4. Independent variable over dependent variable. Are these two equivalent? Yes, they are. So we'll say that Gilberto is proportional. And then lastly, Leanne. We're going to do the same test here. We're going to create some ratios. I don't know why I scrolled up. I could have just used 1, 10, and 2 and 10. So independent variable over dependent, 1 over 10. Is it equal to 2 over 10? No, it is not. So therefore we say that Leanne's relationship is not proportional. Well, you might be asking, wait, why did this happen all of a sudden? I want you guys to take a look at your tables here. So remember how in 1.2 I highlighted the when the independent variable was equal to 0? Right? Take a look at what's different. So here, and I'm going to scroll all the way up. You guys don't need to scroll up, but take a look where I highlighted here. What do you notice is different? So all of the graphs up there were zeros, whereas all of the graphs here, only one of them is at 0. So here, this thing that I mentioned where the graphs that pass through the origin 0, 0 are proportional, right? So in this case, we said that Alana's was not proportional. And we also said that Leanne's was not proportional. Take a look at where they passed through 0. You can even see it in the graphs here. Right? Gilberto's is the only one that's proportional here. And look where he starts. You see how his graph starts at 0, 0? That's what we consider proportional. Alana starts at 0, 5. And then Leanne starts at 0, 10. So lines that start at 0, 0 are proportional, okay? So that's how you can determine whether or not something is proportional. Okay, I'm sorry. That was kind of long-winded. Okay, you guys, we're almost done. Now, what I want you guys to do is I want you guys to go ahead and, you guys are going to finish this lesson up. So you guys are going to do question 2, which starts on page 18, and then you're going to continue on all the way to 20. Okay. I think you guys can use the rest of class time to finish this question, or to finish this lesson. Of course, after you finish your lesson, answer your focus question, Okay, please make sure to answer it. And then if you guys have time afterwards, you guys can work on your homework. Okay, we'll be going over these answers in class on Thursday. Okay, so please be prepared to share, and then we'll continue with 1.4 the next class. Okay, all right, you guys. Take care, and I will see you in